I am going to talk for a very few minutes about value flows. Boy, okay, I get my tech all figured out here. Sorry, thought I had this all working. So value flows is a vocabulary. It's based on an ontology called REA. REA stands for Resources, Events, and Agents. It started out as an enterprise accounting model, but has developed over the years into an overall economic model for networks, which is what makes it really interesting for us. The old traditional double entry accounting doesn't really work very well for networks. It's an enterprise focus, but REA does work. So we think that anything that is looking at climate accounting needs REA or something like REA to make it work. This is a little picture by Kate Rayworth, part of one of her donut pictures. REA describes flows of resources, and as does value flows. It it works for, you can see that little economy circle in there. Value flows and REA work for the economy, but they work for all the other levels that we need to talk about to deal with climate change. And it's a lot easier to think about resource flows through these giant networks if we have a common vocabulary. Definitions. Okay, RE and A. Agents are economic agents who perform economic events affecting economic resources. An agent can be a person or an organization. An event takes action. It creates, changes, consumes, uses resources, transfers resources from one agent to another, transports them from one place to another. We take a somewhat broader view of resources than some people do. So we have useful goods and services as kind of the, a standard definition perhaps. We support money, tokens, credits, things like that. Energy, labor power or work, skills, pollutants of all kinds, air, water, soil, microbiota, positive resources of all kinds in our ecosystem. So really, we kind of need to loosen up our heads a little bit and think more broadly about resources. So value flows works with an input process output model kind of overlaid onto REA. Resource flows using this input output process pattern can be as long as you want. Some of them are circular as much as we can, right? They can loop into each other by channeling resources that would otherwise be waste into a positive stream. By hooking this stuff together in this way, you can track and trace where resources have come from and where they go as far as you have data. This pattern also works at all different levels. You can see kind of this layering of nested processes here, which can be aggregated up to bigger and bigger processes. And then on the right, there's just a couple little examples. On the very right, you can see where there's sort of, these are kind of taxonomies where you have the most detailed level at the bottom, and you can see categorization of that all the way up, right? So there's categorization of processes and categorization of resources. Here's the lowest level, operational. And you'll just see some examples here. You see Sensorica, which Tiberius is associated with. They, Sensorica and Guerrilla Translation are operate with contributive accounting, meaning that they reward people based on their contributions into the resources. Fifth Season is a multi-stakeholder food cooperative that we've worked with. They what's interesting, the multi-stakeholder piece makes it really interesting because they have farmers, they have processors, and they have like consumers, but and they do institutional consumers like schools and hospitals and such. But having that multi-stakeholder thing means everybody has to agree on what's fair, right? It makes it makes for lack of competition and way more cooperation. Fair Co-op is a deals more with cryptocurrency and other financial services. Learn Deep is it's a network of high school fab labs. So these are just examples. This is where you'll see groups using value flows to do their everyday work, plan, execute, um, make stuff happen. So here's we're popping up a level here to something municipal. Reflow is a project we're currently working with that is doing it's a European project that's doing pilot projects in 6 municipalities. Each one is focusing on a different industry. Um, and these folks are looking in Amsterdam. They're definitely looking at both the operational level and the analytical level, and I think that's true of the other municipalities also. Here's another similar size example, provincial. This work was done with a group in Nova Scotia, and they were focusing on fish. They interesting finding. they they found that fish caught in Nova Scotia was being shipped to China, filleted there, and sent back to Nova Scotia for sale. So you can discover lots of interesting things looking at resource flows. Um, they started with kind of a broad analysis that you see here. They from this they took action, right? They created a sustainable fishing cooperative. They hooked up networks with processors and markets and tried to get something local and regional going. And all the way up to global. We were not working with Metabolic when they put this diagram together, but I just think it's a really nice visualization, just to show you can go up as high as you want. Ways to contribute. So people can contribute, are very welcome to join us in the Value Flows project itself. There's a link here for our welcome and getter. If you are interested in using this for your project, we are very happy to help you model your resource flows and map your data to value flows and see what makes sense for you. And we are offering help to the Climate Collabathon for the protocols or whatever might be useful. We're very happy to contribute anything that Value Flows can offer. And I think I have a bunch of links at the end here. Yeah, these are just links to references to the specific things you saw in the slides, more or less in the same order you saw them. Okay, I'm gonna stop sharing, I think. And Michelle is there.
Uh, yeah, so maybe I'll just do the bridge between, because there's like many people out there, and just to put things into perspective, because we did start the other way around, right? We wanted to have the top view, which is Michel Bowen's speech about global climate accounting, and then dive deeper a little bit into what kind of languages you can use to build accounting systems for that, and what are some examples of accounting systems that have been built for that. And so, just to put your presentation into perspective, Lynn, when we discovered the REA, this language to speak about economic processes, it's we were actually looking for how to represent these economic processes in network environments, and we were struggling with whatever was available, project management tools and ERP essentially, because Sensorica started as a distributed network for peer production, for innovation and peer production, right? So we were not running like a corporation. We were not vertically integrated. We didn't have a centralized decision-making process. Okay, we wanted to see how can we do peer production of material things as Bitcoin offers a service for token exchange, right? And it's also a distributed type of organization. So we were thinking, how do you represent, how do you model processes in a network environment where you don't have an hierarchy, okay, in place, and you don't have processes in place like structured, like hierarchical, like within a company. Um, so any accounting models out there, they only tell you the view of the company, okay? And so if you want to represent the whole ecosystem, you end up essentially stitching together views of internal organizations, okay? So one organization producing something and sells something, and the other organization, if you look from the other side, they buy it, okay? So in order to represent the whole network, you have to, using this language, stitch together everyone's internal view of what's happening around them, right? And this NRP, this RIA, this REA was a language that allows you to speak about the ecosystem as a whole without getting lost into everybody's reality in their little corner. Okay, so when you have a peer-to-peer network of production or an ecosystem of companies, whatever, you can use this accounting language or ontology to build resource management systems on top of that, that allows you to manage the whole ecosystem at once. Okay, and have a what Bill McCarthy, the father of this ontology, calls the helicopter view, or the collaboration space view of all these processes. Okay, so if we want to talk about climate accounting at a global scale, it means that you have millions of independent actors contributing to processes that are interconnected together. And I believe, from playing with it for the past, I don't know, almost a decade, that this is probably the way to go. So Michel Bounds is gonna rise us a little bit higher and talk about global climate accounting, and why this is so important. And then possibly it's gonna link REA that Lynn presented with Holochain, which is essentially a peer-to-peer infrastructure that allows you to build these accounting systems, right? In a way that nobody owns them. They're shared, right? And using this proper language to represent the whole ecosystem at once. Uh, was that good enough for you, Lynn? Okay, okay. So